Okay, so in 7-6, we talked about the inverse, finding the inverse of a 2x2 and a 3x3, a square matrix. And then we talked about how you could check to see if it's the actual inverse would be to multiply them together in both directions. So if I had A and then the inverse to A, multiply A times A to the -1, and you should get 1, 0, 0, 1, and then flip it, A to the -1 times A, and you get 1, 0, 0, 1. Okay, we talked about the long way to do these, right, with the 2x2s and then the shortcut. How many of you did the shortcut? Yeah, that's what I would think. Okay, so shortcut is that little Jesus fish, right? Gotta find the determinant, which we're going to talk about a little bit today, of the initial matrix, which is -3 times 1, -3 minus 2 times -2, which is -4, and I get -3 plus 4, which is a +1. And then I would put 1 over whatever that is, so it would be 1 over 1 in this case, times inside my matrix, I am switching the positions on the A and D, so -3 goes here and 1 goes here. And then I'm negating the signs on the other two, so that becomes a +2 and a -2. And then this is just a scalar of 1, so if I just multiply that in, it stays the way that it is. If it was a number other than 1, obviously, it would change the values inside. Questions on that one? Easy stuff, right? 3x3, obviously you can't use that shortcut. You got to figure out how to change the left-hand side so that it looks like the right-hand side. That's your, like the reduced row echelon, 1, 0, 0, 0, 1, 0, and 0, 0, 1. Typically, we start with that 1 in the top left corner, and it's already there for you. And then we've made a tendency of kind of moving our, putting the 0 where the 3 is. So I would say you kind of had two choices here. Either 1, multiply the first row by -3 and then add those two. Raise your hand if you did that. Okay, the other one would be multiply the bottom row by 3 and then add it to that one. Then you don't have to change the signs. How many of you do that? Okay, so we'll do that. So I'm going to take row 3, multiply it times 3, and add it to row 2. Not that the first method is wrong. It's still fine. So -3, -12, -21, 0, 0, and 3. And I'm going to add it to row 2, 3, 7, 9, 0, 1, 0. So I get 0, -5, -12, 0, 1, and 3. And I'm going to replace row 2 with that. Okay, then if we follow the pattern again like we've been doing, we work our way down. We want to 0 where that -1 is. How many of you added row 1 and row 3? Okay, good. So 1, 2, 2, 1, 0, 0, -1, -4, -7, 0, 0, 1, 0, -2, -5, 1, 0, 1. That's going to take the place of row 3. Okay, still need a 0 in this locate. Oops. In this location. Hey. This location, this location, this location, and this location, right? And where you go from here is kind of up to you. We tend to work our way like down and left, right? So if I wanted to get rid of the -2 on the bottom, what could I do? I'd have to multiply row 2 by 2 or -2, right? And then the row 3 by 5 or -5, whichever one I didn't do. And then it would cancel there. But what would happen if I just added row 1 and row 3? This 0 is going to cancel out, right? The 1 would ruin this, but remember you can you can replace either row 1 or row 3 with what you're doing. So if I add row 1 and row 3, instead of replacing row 3 with it and losing the 0 I just got, I can actually replace row 1 with it. So that's what I'm going to do. I'm going to add row 1 and row 3. But I'm going to put it in row 1's spot. So 1, 0, -3, 2, 0, 1, and then 0, -5, -12, 0, 1, 3, 0, -2, -5, 1, 0, 1. Okay, still need to get a 0 here. So at this point, I would still have to multiply. Okay, I can multiply row 2 by a negative 2, and then row 3 by a positive 5. So I get 0, 10, 24, 0, negative 2, negative 6. And then row 3 by 5, 0, negative 10, negative 25, 5, 0, 5. And I'm replacing row 3. Okay, so then we went to the 12. So we said this is 12R3 plus R2. Oh wait, it should be negative. Negative 12. Positive, positive, negative, negative. Oh, we did the wrong one. Jeez Louise. Holy crippity crap. 25, 15, 60, because it's 12 times 5. I did 12 times row 3. Okay, and then I need that 5 to be a 1, so I can do negative 1/5 at this point. 0, 1, 0, 12, negative 5, negative 3. And that replaces row 2. 1, 0, negative 3, 2, 0, 1. And then 0, 0, negative 1, 5, negative 2, negative 1. And the last one I got to get, well, I have to change these signs. This could be positive, negative, positive, positive. And then I got to get the negative 3 to be 0. So 3, row 3, plus row 1. 0, 0, 3, negative 15, 6, 3, 1, 0, negative 3, 2, 0, 1. And that's row 1. So this is like where you draw the line. The left side is at 1, 0, 0, 0, 1, 0, 0, 0, 1. The right side is your inverse. So negative 13, 6, 4, 12, negative 5, negative 3, negative 5, 2, and 1 would be the inverse to A. Okay, and you see how easy it is to make a mistake. You want to be really, really careful. How many of you were on the right track? Maybe you didn't get to finish because of the time, but you were on your right track. Okay. Obviously, you're going to get one of these on the quiz. It's going to take you a good amount of time to do it. You want to be careful. You will get partial credit. Like, you'll get maybe points for every 0 that you can get. You just want to make sure you're really careful. Questions on the process. So, same process as Gosh Jordan, but yeah.
Is it okay to, like, leave the first row, like, by itself until the end, putting out the last 2?
Sure. It doesn't. The order doesn't really matter. I would just say the only thing I would say to stay away from is within a single row, besides the first one, because we use the 1 a lot, don't get the 1 before a 0. If you get the 1s before the 0s and then you have to go get the 0s, you could end up losing the 1. Does that make sense? So always go for it, minus the first one. I think the first one, if it makes sense, most of the time it's not that hard to get that to be a 1. If you can get that to be a 1, it helps you build your way down. It just makes it easier. You don't have to get that 1 first. But it just makes it easier. And then work your way through the 0s before you get the 1s, unless the 1s are super easy to get. Like, unless they were all divisible like by 5 that one time. That's not that bad. But especially if you've got to introduce some fractions, stay away from it as long as you possibly can. All right, 7-7 is called the determinant of a square matrix. So yesterday I told you that it was called determinant, right? But Today we're going to talk about how to use it or how to find it on a 2x2 and a 3x3. So you can actually use determinants to find, to solve the systems of equation, which we're going to get to in the last section of the chapter 7-8. But for right now, we're just going to learn how to find them, okay? So the determinant of a 2x2 is what we talked about yesterday, that Jesus fish looking thing, okay? If I have a 2x2 that is A, B, they call them A1, B1, A2, B2. Then if you multiply B2 times A1 and subtract from it B2 times A1 minus A2 minus B1, then you get the determinant. So it's that same pattern that we talked about yesterday. The diagonal that goes bottom right, top left, you're going to multiply together first, and then subtract from it the bottom left, top right. And then you'll get one number for your determinant. So it'll just say find the value of each of the following, of the determinant of each of the following matrices. So for the first one, I'm going to go in order, -1 or -2 times 1 minus 5 times 3. And I get -2 minus 15, which is -17. For determinant, that's all you need to do. So this is not the inverse. So for B, same thing, -1 times -3 minus 4 times 2. And I get 3 minus 8, which is -5. Easy stuff, right? Questions on determinant. So we use 1 over the determinant times, the altered matrix to find the inverse, but you might just be asked just to find the determinant. That's what it would look like. Then we get into minors and cofactors. So one of the ways to find the determinant of a 3x3 is using the minors and cofactors. I'm going to show you a different way, but this is one of the ways that you use this. The minor of the entry is the determinant of the matrix obtained by deleting the row in the column that entry is in. So if I ask you to find, let's say I have just the matrix that is 1, 2, 3, 4. And I ask you to find the minor of row 1, column 1. So minor 1, 1, row 1, column 1. Then what you want to do is actually cross through the row and the column that cell is in. So if it's row 1, column 1, I'm crossing through row 1 and column 1. And whatever's left is your minor. So it would be 4. And then I would repeat that process for each of the ones. So if I did the minor of 1, 2, that's row 1. Or sorry, I went the wrong way. That's row 1, column 2. And then what's left is the 3. And then if I did 2, 1, that's row 2, column 1. What's left is the 2. And if I did row 2, column 2, that's row 2, column 2. What's left was the 1. So to find the minor, you are crossing out the row and the column of whichever cell you're looking at. If it was a 3x3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you wanted to find the minor of 1, 1, you're going to do the same thing. You're going to cross through the row and the column that cell is in. Now you have 4 terms left, and you have to find the determinant of those 4 terms. So this would be equal to 9 times 5 minus 8 times 6. Or 45 minus 48, which is -3. If you wanted to find, I'm not going to work my way all the way through because we're going to work through an example, but if I wanted to find the minor for 1, 2, this would be row 1, column 2, and then I'd be finding the determinant of what's left, 4, 6, 7, 9. So that would be 36 minus 42, or -6. So if it's a 2x2, you're crossing them out. There's only one number left. That is the minor. If it's a 3x3, you're crossing them out, and what's left you have to find the determinant of. Questions on the minor? Again, we'll work through an example, but while we're here, we'll also talk about the cofactor. So the cofactor is exactly the same as the minor, with the exception of the sign change on some of the locations. So if you look here, the cofactor is going to be whatever you find from the minors, but on a 2x2, the ones in the top right, bottom left corner, you would change the sign on. So if I took this and actually put it into what the minors would look like, it'd be 4, 3, 2, and 1. This would be the minors. And the cofactors, I would change the signs on the 3 and the negative and the 2. So the cofactors, the first one's going to stay the same. The second one's going to change sign. The third one's going to change sign. And the fourth one's going to stay the same. So second and third in that order are going to change signs. If they were positive, they become negative. If they're negative, they become positive. Okay, and then for a 3x3, the ones that are in that north, south, east, west location are the ones that change signs. So let's just say that after I found my minors, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? After you found all your minors, right, in that order. Then the second, starting with the second one, every other one is what you change signs on. So it would be row 1, second column, row 2, first column, row 2, third column, and row 3, second column. All right, this says find the A minors and B cofactors. So for A, the minors, I'm going to do minor 1, 1, minor 1, 2, minor 2, 1, minor 2, 2. 1, 1 would be crossing through the row in that column, and I'd be left with -6. Minor 1, 2, row 1, second column, I'd be left with 3. Minor 2, 2 would be second row, or sorry, 2, 1, second row, first column, and I'm left with 5. And minor 2, 2 is second row, second column, and I'm left with 4. Then the cofactors, I changed the sign on the second and the third one. So cofactor 1, 1 would stay -6. Cofactor 1, 2 would become -3. Cofactor 2, 1 changes to -5, and cofactor 2, 2 stays +4. So just the middle two change sign.
So you only change the sign if it's like not the same number? Like it's not 1 and 1 and 2 and 2?
Sure, you can look at it that way. Yep, yeah. So if it's 1, 2, and 2, 1, if the numbers are different on the row and the column, those are the two you change. For this one, obviously it changes when you get to 3. Yeah. All right, when you do the 3x3, so this time I'm going to write it out a little bit more clearly. Minor for 1, 1, minor for 1, 2, and minor for 1, 3. You're crossing out row 1. For 1, 1, you're crossing through row 1, column 1, and you're going to find the determinant of what's left. So I'll go back and do that work. For the second one, you're doing row 1, and now you're doing column 2. What's left is -3, 1, 1, 1. And again, I'm going to go back and do that work. And then for the last one, it's row 1 and column 3. So it would be -3, 2, 1, -1. And then I'm going to go back and find the determinant of each of these. So this would be 2 minus a -1, which becomes +1. This would be -3 minus 1, which is -4. And this would be 3 minus 2, which is 1. Then I'm going to repeat that whole process for row 2. So minor 1, 2, 1, minor 2, 2, minor 2, 3. This time I'm crossing through row 2. First time is column 1. So I'm going to find the determinant of 0, 2, -1, 1. Then I'm going to do row 2, but column 2. So I'm finding the determinant of 4, 2, 1, 1. And then the last one is row 2, column 3, 4, 0, 1, negative 1. And I'm finding the determinant of each of these. So 0 minus a negative 2 becomes plus 2. 4 minus 2 is 2. Negative 4 minus 0 is negative 4. And then I get row 3. Column 1 would be 0, 2, 2, 1. Column 2 would be 4, negative 3, 2, 1. Column 3 would be 4, 0, 1, negative 1. And then you're changing the signs. So those are the minors. You're changing the signs for the cofactors on every other one starting with the second one. So cofactor 1, 1 is going to stay the same. Cofactor 1, 2, that negative 4 is going to become a positive 4. 1, 3 stays the same. 2, 1 changes. 2, 2 stays the same. 2, 3 changes. 3, 1 stays the same. 3, 2 changes. 3, 3 stays the same. So one of the ways you use minor and cofactors is actually to find the determinant of a 3 by 3 matrix. In years past, I have taught this method, and then there's a second method, and nobody ever uses this method. So I'm not going to teach you this method, okay? I'm going to teach you the one that everybody likes. So you can skip expand cofactors, you can skip this example, and you can skip definition. Well, actually, yeah, skip this one too. And come to the determinant of a 3 by 3 matrix and add in a little note so that you can actually do a different method. So that is if you want to learn the other way. There's a way to do it with the cofactors. You would find the cofactors, you'd multiply it in on the determinants of what's left, okay? The other way to do it is whatever your matrix is. So if you have a 3 by 3 matrix, let's just say it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your 3 by 3 matrix. Then the first thing you're going to do is duplicate the first 2 columns to the right of what's already there. So your first 2 columns are 1, 4, 7, 2, 5, 8. How many of you already remember this from Algebra 2? Once you duplicate. No? You totally did this. In Algebra 2 Honors, you totally did this. Okay, then you almost do the order of the Jesus fish in terms of diagonals, okay? You're going to multiply down along the diagonals of these 3. Now you know. Of these 3, okay, first. So you're doing top left, bottom right diagonal, just like we do the Jesus fish. That one comes first, right? So I picked really bad numbers because they're huge, but you get the point. Okay, so I would multiply 1 times 5 times 9, that's 45. I would multiply 2 times 6, that's 12. Times 7, that's 84. And I would multiply 3 times 4, that's 12. Times 8, that's, right, 96. Yep. And then I would add all these 3 numbers together. I don't know why I picked these numbers, but I did. 9, 129, 96, 5, 12, 225. Okay, then I go back the other way. So you go this way. So 3 times 5, that's 15 times 7. 15 times 7, 105. 8 times 6 times 1, 48. 9 times 4, 36 times 2, 72. And then I add those numbers together. Oh, this was a really bad example, but it works. Okay. So then you take the number you got from the first diagonal, which is 225, and you subtract from it the number you got from the second set of diagonals, which in this case was 225. And you'd get 0. So the determinant of this matrix is actually a 0. Okay? It's probably never going to happen again. Which is why the order is so important, right? Because if they were different numbers, then I switch them around, it's wrong. So you got to make sure, think about the order you do your fish. You do the top left, bottom right diagonal first. It's the same for this, okay? So let's work through one together. This is when you pray for zeros to happen, because zeros cancel out whole rows, right?
Wait, does that mean that the other one that we just did, does that mean that it doesn't have an inverse?
Correct. Yep. It still has a determinant, but it doesn't have an inverse. I don't know if you guys heard him, but if you have a determinant, if it's 0, then you can't have an inverse, so yeah. But it can have a determinant. All right, so we're going to start here. And the homework says expand by cofactors. Ignore it. Just find the determinant, okay? That's the expand by cofactors is the other method, but you can use what we just did. All right, so the first step is to rewrite the first 2 columns. All right, so again, columns, and be so careful there because you leave off that -1 and you mess up the entire thing from here on out. Going top left, oops, a daisy, with my highlighter, top left, bottom right. So 2 times -1 times 0 is 0. 1 times -2, -2 times 3, -6. 0 times 1 times 1, 0. Add those up. -6. Go back the other way. 0 times -1 times 3, 0. -2 times -2 is 4 times 1 is 4. 1 times 1 times 0 is 0. Add those up, and I get 4. And then I do the first diagonals, -6, minus the second diagonals, 4, and I get -10. On your graphing calculators, there's underneath the matrix menu a little thing that says DET. That means determinant. So if you were to type this in under the matrix of A, you would type in the 3 by 3, and then you go in and you hit determinant of A, you'd get the answer -10. So it's a good way for you to check your answers. But again, you won't have graphing on your quiz or test. Don't become reliant upon it. Okay, one more, and then you're done. So 17 minus 5 is 12. Okay, and then I'm going to show. All right, so once you've entered in your matrix, so if I go to second matrix and I go over to edit, I've already entered this one in. Then I can get out of that menu by hitting second mode to get to the quit. And then I would go back to the matrix menu, so second matrix, arrow over to math, and the DET is determinant. Bring back the name of the matrix by going second matrix, and it was A, hit enter, and there it gives you your determinant. It will do it for a 2 by 2 or a 3 by 3.